Hello students, today I will discuss with you the properties of the hydrides of the nitrogen family. In a nitrogen family, there are nitrogen, phosphorus, arsenic, antimony, bismuth. And in the nitrogen, the electronic configuration is 1s2, 2s2, 2p3. That is, there are 5 valence electrons. There are 5 valence electrons. So they require 3 more electrons to complete their octet. That's why they all form trihydrides only. They all form trihydrides only, like NH3, PH3, ASH3, SB, and BIH. These are the trihydrides of the nitrogen family. Now, let us first of all discuss their boiling points. The trend of boiling points is like this. Generally, boiling points increases down the group, but ammonia has unexpectedly higher boiling point. And what is the cause? Because in ammonia molecules, there is hydrogen bonding. In ammonia molecules, there is hydrogen bonding between N and H. Due to this hydrogen bonding, the boiling point of ammonia is higher in comparison to PH3 or ASH3, etc. And why down the group boiling point increases? Because they don't have hydrogen bonding, but due to increased van der Waals forces down the group, because down the group molecular size increases and van der Waals forces depends on the molecular size. So down the group molecular size increases, van der Waals forces increases, due to which boiling points increases down the group. But the unexpectedly higher boiling point of ammonia is due to hydrogen bonding. So if we talk about boiling points, then this is the trend. And if we talk about volatility, then as volatility is just reverse of the boiling point, so trend will be just reversed. You have seen, if I compare, this was the trend of boiling point. This was the trend of boiling point. And now, this is the trend of volatility. This was the trend of boiling point. And this is the trend of volatility. You can say just a reverse of the boiling point. Because volatility is the tendency of the liquid to go into the vapor phase, and it is obviously reciprocal of the boiling point. That's why volatility has just reverse trend of the boiling point. So this was the volatility. Now the new property is thermal stability. Thermal stability. Thermal stability decreases down the group. This is the trend. Thermal stability decreases down the group. And what is the cause? Down the group, molecular size increases, due to which bond length increases. Down the group, molecular size increases, due to which bond length increases, and bond becomes weaker, and hence thermal stability decreases down the group. And if I talk about reducing nature, next point is reducing nature. Reducing nature is just the reverse of the thermal stability. So it will increase down the group. This is the trend. And what is the explanation? What is the cause of increasing thermal stability? What is the cause of reducing nature down the group? Because thermal stability decreases down the group. Thermal stability decreases down the group. Reducing nature is just a reverse of the, you can say, or the reciprocal of the thermal stability. So reducing nature increases down the group. This is the explanation why reducing nature increases down the group. Now the next property is boiling. Boiling point we have discussed. Next property is bond angle. Bond angles decreases down the group. Bond angles decreases down the group. And what is its cause? See, the electronegativity of nitrogen atom is higher than phosphorus. So the NH electrons are very close to nitrogen, but electronegativity of phosphorus is less, so they are little away. As nitrogen cloud is very close, so there are stronger repulsions. Stronger repulsions, and due to electronegativity of phosphorus is lesser, the bond electron pairs, they are little away, so there are weaker repulsions. As there are stronger repulsions, the bond angle will be higher, and there are weaker repulsions, the bond angle will be lesser, and similar trend will go down the group. ASH3 will have lesser bond angle than BH3, and SBH3 will have lesser bond angle than ASH3, and so on. Because down the group, repulsions between the bonding electron pairs decreases, due to which bond angle decreases. This is the explanation for the decreasing bond angle down the group. And now the next property is basic nature. Basic nature of the hydrides, and basic nature also has the same trend. This is the trend. Basic nature decreases down the group. And what is the cause? Because of high electronegativity of nitrogen, the bonding electron pairs of the NH bonds, they are more close to nitrogen, and this lone pair is more available for donation, and this lone pair is less available, and down the group same trend will continue. So again, due to high electronegativity of nitrogen, the bonding electron pairs of the NH bonds, they are more close to nitrogen, so this lone pair is more available for donation, and this lone pair is less available for donation. That's why ammonia is a stronger base than PH3, and PH3 is a stronger base than ASS3, and so on. So these are the properties of the hydrides of the nitrogen family, and likewise the properties of the oxygen family and halogen family we will discuss. But you can say these properties are the basic properties. If you know these properties, then there will be no difficulty for you to discuss the properties of the hydrides of the oxygen family or halogen family, etc. Thank you very much.